Welcome to this Julia course, who's one of the activity of the SciAm student chapter at the University of Pavia. So this will be a sort of a reading course in the sense that we will give you an introduction to the Julia programming language. Max will do the probably first part. I will do the second one and the say project. And if everything goes smoothly, it will be a transversal course of the PhD program. So if you need credits and so on, it will be how many credits? 3 plus 1? Only 3. No plus 1. Okay. So only 3 credits for the attendance. There will be no no exam, nothing. Okay, so it's just attendance plus there might be some, as I said, it's sort of a reading course, so we will do the first part split between me and Max, and then you will probably, some of you will present a smaller topic about Julia or will help us extend some code that we are writing for one of the courses here in Pavia. And yeah, so that's basically it for the introduction. It will be every Wednesday until the end of the year here in Aula Beltrami. And yeah, so first 10 minutes, Paolo will give a brief introduction to Julia and just with a brief example explain why it is worth learning this language, and then Max will start with the first topics, and we will help you also install Julia on your laptop, every laptop, also Windows. So thank you.
Okay, thank you. So, yeah, that's I don't know what qualifies me to give this first part of the presentation, but anyway, so I wanted to start from the from oh yeah. Okay. Whoop. So I wanted to start from the Julia main page. So Julia is supposed to be a fast, dynamic, reproducible, many things, general language. For what we're concerned, what we're interested is it's fast. And the reason why it's fast is blazingly fast, absolutely. The reason why it's fast hopefully will be somewhat clear in the next 10 minutes, let's say. I give myself 10 minutes. So you might be familiar with Python. So when you write Python code, the way it's supposed to work effectively, you have a Python interpreter, which is a program on your laptop that reads the Python code and transform this code into bytecode, which is a specific sort. It's some sort of machine interpretable code that will be run by your computer, and so this adds a lot of overhead to the execution of programs. So this is why usually Python can be well, usually it's relatively slow, especially compared to other high performance languages such as C, C++, even other languages like say C#. It's a different class of languages, but it's slower. And the reason why is this almost compilation, which is not really compiled. The advantage of Julia is that it aims to be as expressive and as simple as Python, while being possibly as fast as C code. Okay, so actually compiled to machine code. Okay, and the reason why this is interesting, and I just wanted to give you a very simple example of how fast Julia can be. So I wrote three simple scripts, which we are going to look at. No, first we are going to look at the scripts. Okay, so first I have. Is it turn off the lights? Anyway, there's really not much to see here. Maybe I can do this as well, so you can. Okay, so the whole code fits into one into the whole screen. Okay, so it's a. Let's say you want to do some form of computation. So you want to compute a Fibonacci, the nth Fibonacci number. So this is the simplest code you can possibly write. It's recursive. Is this optimal? No, but we're going to keep the playing field as fair as possible and write recursive code for Python, C, and Julia as well. So you have this simple function, and let's just see how many times. Let's test 10,000 times. We'll try to run the Fibonacci function to compute the 20-second Fibonacci number, and then we'll look at the mean execution time. Okay, so this is very straightforward. So this is the code for Python. It's very simple, very readable. Let's look at the Julia code. Okay, sorry. I realized I only have one hand and I need two hands to type. So oh, that's actually a no. Oh, okay. Okay. Okay, so this is almost the same thing. The Fibonacci function is exactly the same. The way I compute the time is slightly different, but for the sake of simplicity, let's say it doesn't make any difference. It's a very simple function. Okay, if I compare the code with the Python code, it's almost the same, right? You could, I mean, if you look from far away, you probably could not distinguish the two code. So this is a very powerful thing for Julia in this case. But we can okay, let's do something different. Let's see. I wrote a simple script that runs the files that I showed you before. And if I test the script 10,000 times and compute the average execution time, you get 47 microseconds per execution per function call. Okay, so I don't know what this numbers tells us. We must compare it to Python, for example. Okay, so now we have to wait some time because again, so the main point of with Julia is that it's much faster, and you can see from the fact that it's 1 millisecond. This is seconds. So yeah, we have 1.4 milliseconds. So effectively, there are almost 3 orders of magnitude of difference between the two execution for still a very simple code. Okay, so this is surprising, and just for the sake of it, I also wrote some C code that does exactly the same thing as the other case. So computes the 20-second Fibonacci number and we just do this for, let's say, again, 10,000 times and compute the average execution time. Okay, now, if you, just by feeling, it was much faster, but, for sure faster than Python, this is easy. And if we look at this, we have 80 microseconds as an average execution time for each function call. But okay, so you can get a sense that how fast it is, how fast Julia is, because it's 47 microseconds, C is 80 microseconds. Okay, so let's not just go around saying that Julia is faster than C code, because that's not the case. It's just in this particular instance, it is slightly faster. Let's say it's comparable, same order of magnitude, okay? But if I want to, okay, this is a very simple example of C code, but again, writing C code is difficult. Sorry, let me, it's difficult with a single hand, but I think I can do it. Okay, so it's much more involved writing C code than writing Julia code, I'd say. And what we obtain if we write Julia code in a proper way, we obtain performance which is similar to C, but the expressivity, say, verbosity or clarity of Python. Okay, so that's the whole point. Hopefully, well, it's not much, but that's mostly it. So I think Max will present now how to install and then move onto Julia. So hopefully this is a good enough at least explanation why we should be interested in Julia, especially if you look at least looking at the computational point of view. If you write say some scientific code, writing scientific code with C is extremely painful because you have to write writing matrices and writing vectors and performing linear algebra with C is very painful. So with Julia, it's much simpler. It's as simple as Python. So I think if we can obtain the same speed as with C, but with a simpler language, I think it's worth at least exploring. So yeah, that's my 10 minutes. So I'll give it over to Max.
Ok, stacca anche la condivisione. Okay, so now we see how to install Julia first of all, and then move on the first part of this course. So I ask you to go to this link. So you search for Julia online, or directly type the link that is julialang.org. If you have a PC and you want to start, I mean, you don't have to install anything if you don't want, because we only explore even an online resource to make exercises. So if you don't want to install anything, you just skip this step. Otherwise, if you want to try some code meanwhile in the lecture or something, you have to do the installation. So please, it's really easy to install, so follow all together and do it in not many hours. So if you reach this site, julialang.org, you go to download, and you have different commands to copy and paste if you have a Unix, so Mac user or Linux user or Windows user, but the site automatic find the right command. So you just copy this or whatever you want. Proviamo. And you open a terminal. So to open the terminal, just Windows key and CMD, or I don't know what in Apple, and then paste the command. Do you agree? Yes. Publisher, yes. Agree with all the things that maybe take some times, depend on your machine. I don't know. It takes, okay. And at the end, you can check if you have installed it correctly, if you have already done this. So just close your terminal, reopen it, and type Julia, then enter, and watch if it works. It takes some time. If there is someone that have some errors, ask to Wablo. And so if you type this without restarting the terminal, probably this not work, but you have to close it, reopen it, and then if you press Julia, hopefully there is no error, but even Julia. So, eccoci, easy. And so you have Julia, you have your version of Julia, and the official sites. So please let me know if you can get at this point. Okay, some say yes. If someone, okay. And now we can start do things like this one. And so for the program of the course, at least for the first part, for the end of the course we will see, and if any one of you is interested in some particular topics, please email us or tell us that we cover it, or maybe you help us cover it. So we will see the documentation, the official documentation of the language that is on the site as before. You go in documentation and something like this appear. And this is like a book that we follow for the first part. And we probably do some exercise that is on this site. You can do on your local machine, or even the site is very good. That is something like this. You have to sign up and not this lecture, but probably the following ones. We see something on this side, and that is so. Just the first part, we have to study something about the syntax, about how to define a function, about to use if, else, and very basic syntax. So we go through the documentation. We will see it almost everything in the first part that cover installation that we have done, variables, numbers, integers, numbers, and floating point numbers, mathematical operations like usual operations, complex and rational numbers, strings, function, control flow, and scope of variables. This is really basic, and we have to do it. Then there is types and so on, and we will see later. So for the installation, the only things to see is the help of Julia. That is really helpful. So the documentation inside the program. So if you are here, you can just type the question mark, and the Julia turns in. Okay. turn on help, okay? And then you can type something like function, and he briefly tells you what is a function, okay? And we will see for another important feature, and that it's so. First of all, variables, how to define variables. This is straightforward, like many other languages. So you can assign a variable just typing it. Okay, this is. Okay, and you can do operation with variables. So now if I press x+1, okay, I have x that is 10, so x+1 is 11, and you can modify the variable. So I can now assign it to 3, and that is 3. Okay, that's good. This is for the moment. We don't care too much about types. Okay, we will see. So you can do whatever you want. So Julia is very flexible in the name of variables, so is of course case sensitive. So if I try to do something like big X, I have the big ones and the small one, of course. I can type in strings strange things, but you can even use strange dictionaries for the variables. So I mean, I don't suggest maybe do something like this. Otherwise, if you put your code on GitHub, I don't really understand what this stands for. But that is really interesting. You can do this one. So you have LaTeX inside Julia. So if you press \delta and then tab, you have the delta symbol of LaTeX. And now you can use like every variable. Okay, so now we have delta that is equal to 1. Okay, where delta is the literal delta. Okay, someone have problems? Okay, okay. And you can do whatever you want. A little comment about this. Probably if you use some text editor, like VS Code or something else, probably tab is already taken from extensions. So if you have Copilot or I bot that suggest you something, or auto-completion, something else, maybe tab is already taken. And so if you write \alpha and then tab, nothing happen. Okay, this can happen. But if you install the extension of Julia in VS Code, you have control space or control dot. I don't do this. I have already installed Julia here, so I can show you. But if you have any problem, try with control space for auto-completion of Julia. Okay, and that is. There is another important things. For example, there is this symbol. Suppose that you don't know what is this symbol. You can copy it. Just, just take it and copy. Okay. You go to Julia, in Julia, question mark for help. You paste the character that you have copied, and then press enter. And Julia said how to write it. Okay, so for delta is not helpful, but I don't know if you have something like this one. Probably you don't know how to type it, so you go, you copy it, help, and there is a lot of stuff that can do this symbol, but even how to write it. Okay, and okay, that's it. Another important thing that is strange respect to other languages, that you have the some constants that are defined in the languages. So, for example, p is the p, okay, and even if you write p, it's still the p, okay. But if you try, what happens if I try something like this? So p equal to 3, it takes an error, okay, and that's fine. But I have error only in the global scope. What that means, we will see probably in the next lecture. In Julia, you have global scope and local scope. Global scope is where I define variables that are available in all the parts of the program. So I have defined x before, and I can use it pretty everywhere. Local scope is defined, for example, if I define a function, let's try this, so call add3, it takes an argument that is called a, and I want to add 3. Okay, we will see how to define functions just to make an example. Now I define p equal to 3, and now I am inside a function, so in a local scope, okay? And now I return a plus p, okay? And this is my function. So I try to use this function on something easier, like this. Okay, so first of all, I don't get any errors before. I can define p equal to 3, where p is the p number, and I don't get any error. And now I try to add p, that I try to define like 3 to a, and now a is equal to 1. So probably some of you are confused on what can I accept, but there is the possibility to shadow the constant of the languages, okay, with variables. And you can do the same with functions. So I have the function to square root, and I cannot assign 100 to square root because I have to use it to do the square root, okay? But if I do the same as before with a square t, now I am allowed to define a square t equal to 3 and returns again 4, okay? This I have to mention at least once, so you know that that exists. So you can use it, but I strongly suggest you don't do it, otherwise you can get strange errors. And that's it. So there is a particular name for variables that is 3 underscores, this one. So make an example. This one is a array or vector, like in MATLAB or other languages, and if I ask the size, it takes 2 rows and 2 columns, okay? And I can unpack this, so I can call something like this. So the output is 2 and 2, and I can assign it the first 2 to x and the second 2 to y, and okay, so now x is 2 and y is 2. But if perhaps I don't need the second one, I can use this symbol, so 3 underscore 1 near others. So now x is still x, but this one does not exist, okay? It's just say skip this value. So in Python is only 1 underscore. In MATLAB you have the tilde, and now we have this one. Okay, so for printing, the REPL already done it is. So if you type x, enter, you see what is x, okay? But if you compile it or use some text editor for the printing, you have these commands. So print line, okay? And prints whatever is inside the parentheses. Okay, there is some rules for variables. the built-in syntax such as else, try, if we can't assign it. Even in local scopes, we can do it. And that is just to make an example. Here there is a strange symbol, and you just question mark, copy and paste, and then you get how to write it, and that's it. For the assignment of variables, you can do even something like this. So you can do b equal to 2 plus 2, and then a that is b plus 3, and you get 7. But you can even concatenate these. So here I put b, and then plus 3. So is only syntactic sugar, so is exactly the same code as before, but in one line. And you have a that is 7 and b that is 4 as before. Okay. Important things, make it with an example. So I make a vector with some random numbers. Now I take b and assign to a. Okay, so I have a and b that is equal vectors. Okay, so I can maybe decide to modify the first entry of the a vector and put it to 42. So now a is something like this. Okay, I modify the first one. So first of all, this helps for two things. The first thing is that Julia starts indexing by 1 and not by 0. Okay, like MATLAB. So the 1 is the first one, and 0 there isn't. But I make a copy b of a. So now if I try to print b, what happened? I get this one. Okay, why? Because assignment is due with referring to the element and not copying it. Okay, like Python is the same. And this is very important. Otherwise, you get bugs and adds to the bug. And that it's for this one. So integers, we have of course a lot of type for integers and unsigned integers. We have int 8, where int stands for integers, and uint that stands for unsigned integers. So we write the sign, only positive integers. Okay, and 8 or 16, 32, 64, 128 is for the number of bits. Okay, so if you don't know it, bits is only a binary code. So if you have int 8, what does it mean? That you have 8 bit, okay, that is this one. And everyone you can put it as 0 or 1, okay, and 8 bit is 1 byte, okay. And so if I can only use this one, I have a maximum number and a minimum number that I can represent inside int 8. Okay, how this works? The first one is for the sign, so 0 for the plus and or vice versa. I don't know. And you remains 7 bits to put the value. Okay, so the bigger ones is positive 1 and all 1. Okay, that what does mean that this one is in binary. I mean, you have only 0, 1, so this stands for the 2 to the power of 0, 1, 2, dual 7, 7, and so the maximum number is the sum of this one. Okay, so you get the sum of 2 to the power of e from E from 0 to 7, that is this value. I think, no, this is 6, because I start from 0. So I have 7 bits, but starts from 0. So this is 6, and the sum is this one. So the largest number is this one with the plus, and the lowest is the same but with the minus. Okay, and same for the 16-bit, 32, 74, and so on. Okay, and of course, unsigned integers takes 0 as the smallest one, and you go even to power of 8 because we have 1 bit more, because you don't need the sign. An important field, we have bool. Bool is false and true. That can be represented with only 1 bit, because 0 or 1, that is only 1 bit, but as in other languages, it takes 8 bits, and not 1 for the convenience. Okay, okay. Same for float. You have float of you can take space of a lot of space. So 16, that is half precision, 32, that is the single precision, and 64, that is the double precision. Which one is a standard for modern machine? 64 is the standard for the CPU. So if you try to write an integer is int 64, we will see, and a float is float 64. If you use GPUs, the standard, I think, is float 32 otherwise. So I have a number 1. Which type of int is this number? You have type of command, and you can see which type this is. Okay, so I think that in all the machine here you get int 64. Okay, and okay, so we take this one because modern computer has 64-bit system. You can even print this command that is sys word size, that tell you how many bits are using your machine. So in this case 64. And okay, so how about if I type a larger number of int 64, Julia have automatic upgrade and downgrade of the type. Okay, so if I try to I don't know, type a very, very big number, like this one, I take int 128, because in 64 bits it can't handle. Just for curiosity, we type numbers in 10 bases, decimal basis, that is the standard one. But you can type in other bases, so you can use the 16 basis or the hexadecimal basis. Okay, and to do it, just put 0x and then your number. Okay, so you do something like this. So if you want to write in hexadecimal basis, you write like this. What this means, that is 1 times 16 at the power of 0. So it is 1 in decimal basis. If you do something like this, is 17 in decimal basis. I mean, it can be useful. And since we have 16 bases, you can go through the letter of F. Okay, because you from 0 to 9, that is 10, and then A, B, C, D, E, and F. Okay, you can type in binary, so just put 0B and then the binary code. Okay, and you can even write in octal. It is base 8. It is what it is. You can do a lot of things. So we have seen that we have, when we choose a type, we have a maximum and a minimum number that we can represent, okay? So if you don't remember it, or just compute it or ask to Giulia, so I can try to do this one. So I asked Giulia which is the maximum number that I can type with 32 bits and integers numbers, and he gave me this one that is probably 2 to the power of 31 minus 1. This one I can try, and hopefully, okay, nice, it's the same, okay, and the same for the minimum number that I can represent. So type min in 32, I get this one, that is the negative one. And what happens if I take the maximum and add 1? I don't know what you expect. In Python, probably you have automatic upgrade, I think. I don't know. In MATLAB, some errors. But in this case, I have to do with 64. Okay. So the maximum number in int 64 is this one, and if I add 1, I take a negative number. Why this happen? Because the overflow in Julia is handled like this. So overflow behavior is circular, okay? So if you try to go up the maximum number you can represent, or you have to upgrade, so pass to int, I try to explain this better. If you do this with int 32, Julia automatic upgrade to int 64. That is the standard one, okay? But if you do this with int 64, that is the standard one, the standard operation now is just go circling, okay? Okay. Otherwise, you can specify that you go deeper and larger and use int 128 or big int, that is this one, that don't have a fixed number of bits. Otherwise, this happen. And I think that there was a nice bug in a game in 20th century that's called Civilization. I think there is Mahatma Gandhi in Civilization that is really calm, and we have the lower level of strength, so that is equal to 1, and there is a poison that decrease your level of 2, and the Mahatma Gandhi, when increased by 2, takes circular and becomes the strongest in the game. And I mean, you have to to take care about this. If you try to divide integers number, you have the integer division, that is the div that we see before. So for integer division, that is this one, backslash div and tab, 3, I take 1 because truncate and takes the integer, okay? Floating points, we have floating points, you can represent like this. The standard is like before, 64 bits. And okay, you can represent in many ways. The 0, you can hide it. So 1 dot is like a 1.0, 0.5 is like 0.5. You have a negative sign and this representation. So this one is exactly this, 1 times 10 to the power of 10. And this one is 2.5 times 10 to the power of minus 4. And it's okay. The E letter is for float 64. For float 32, you have the F letter. Same as before, but with the F. And okay, and even for this, we have type of. So type of 1 dot, we have float 64, that is the standard one. Okay. Okay, just a curiosity. 0.0 and -0.0 is different in when you represent with bit because there is the code to transform a number in bit. The first one is positive, so get the 0 for the sign, and the second one is negative and takes 1 for the sign. But if you ask they are equal, they tell true. If you don't want this, there is even the is equal function. And if you ask if 0 is equal to -0, you take false. It is what it is. Okay. Special numbers, we have this one, the inf in different values, and the none. Okay. Inf, of course, is the greater one, minus inf is the smallest one, and none is not a number, it's different to any number. Okay, so if you try to do something like that, none is equal to 1, false. Okay, none is a number that is different to every other numbers, even of himself. So if you try to do this thing, you get false. Okay. If you want, you have the is equal that this time takes true. So I think is equal like bitwise comparison. Okay, and in this case I get false, in this case I get true, and this one is like this. Go in a more intuitive way, maybe. And you have a lot of operation that we have to know, and we have to care about it. So the operations are extended, okay, as we think in limits analysis. So this one gets 0, this one gets inf, minus inf, inf, and for this one I get none, and so on. Okay, so if I add infinum, inf I get inf, minus inf I get inf, and none for the undefined analysis limits. That is okay. We have type min and type max for float, and it's okay. In floating is of particular interest the epsilon precision. How to get it? Just type this. Okay, so you can type eps and then the float that you are using, and this is the smallest number that you can represent. Okay, of course you are in a computer, there is a finite number of memory, and you can represent all the number. Okay, and eps without nothing is the takes the standard of your computer, and you can even do something like this, next float and prev float, just for curiosity. So if I have a number, this is something like this, I can type next float and shows me the next closest floating point. Okay, you can even the prev float, that is the smallest closest floating point, and you can even do something like that, eps1. This is not type nothing because okay. This is the I have to do with float, and this print the difference between 1 and the closest number. Okay, in floating point precision, and we know that floating point precision is not uniform. Okay, so it's denser around 0. So in fact, if I take this one, I get something like the epsilon precision, but if I do the same with 1 million, I take this, okay, because the next closest number is much away from this. Okay. I think that about this we are okay. Oh, we have big int, a big float. That is big int. You can type any integer as long as you can do, and you can do in a lot of ways. This one, that is probably the straightforward, or with strings, or with parse. Parse takes this one, that is a type, and another things, and convert these things to this type. Okay, and okay, and similar for big float. You can use a float of arbitrary precision. Okay, and okay. Okay. Now another feature of Julia is this one. So the times sign can be omitted in obvious situation. So what does it mean? That if I take x equal to 3, and now I can compute 2 times x without writing the times. Okay. But of course you can't go really crazy with this because if I type xx thinking of x times x, this not work. Why? Because there is the possibility that x is a function and I try to apply this to x. Okay, so simply don't know how to do and takes an error. Okay. And just it is. Okay, this one is another things to do. You can do something like this one. Okay, so x is 3, I take 2 times 3. Okay, but I can't do the reverse thing because as before, if x is a function and I try to apply it to x minus 1, I mean, the function notation wins because I don't have alternatives. If I really want to write like this, I just put this and it's okay. Okay, and that's all for this part. Mathematical operation, try to go much faster maybe, is just operation. So you have the plus, minus, times, division, integer division. This one that is not the backslash of MATLAB in this context, maybe, but it's just something to don't use. Ho sentito un blip strano. Wow, lo si è disconnesso. Male. Ok. Allora ho sentito solo il blip strano. Bene. Power and reminder. So you take the division. It's just a reminder of the division. Okay, so 5 is a reminder of 1. Okay. Okay. So a lot of examples, and it's okay. You have the for Boolean types. You have the AND, that is this one. Okay, and the OR, that is this one. And we have bitwise operators that probably you think that are not useful, but if I can, I try to show some example in which they are useful, just to give some important today in the exercise part. And now you see that there are a lot of strange symbols. You can copy it, question mark, ask to Julia, what is this? And you can type XOR, and it tells how it works. Okay, so there is the tables of the XOR. XOR is equal to true when the two inputs are different. So if you have true, false, you get true, false, true, true, double true, false, double false, false. Okay, and so on for a lot of there. Okay, there is a sum of example, and okay, you can update like this. So what does it mean? You have x that is 42. and I want to add 3 to x, I can do something like this. Okay, but if I am lazy, I can do something like this. Okay, okay. Okay. Now dot notation. Dot notation are really helpful in many cases because it's really powerful in Julia. So this one, if some of you know MATLAB, probably already know this. What happened? Just I have a vector of elements 1, 2, 3, and only the power, maybe you don't know what happened, but if I put the dot notation, just take the power of every element, okay? So 1 at the power of 3 is 1, 2 gets 8, and 3 gets 27. But you have this macro. If you have to do a lot of operation with dot notation, okay, you can just put like this. So at dot, and then your operation, and Julia know that you want to do every operation with the dot. Important, powerful things you can use with sin. So sin is a built-in function that computes the sign of a number, and you can dot it to do it in a matrix or a vector. You can do something like where is the I don't know, but if you have something like this, okay, and you want to update every entry of the vector, you can do dot notation plus equal 3, and you add 3 in all of them, okay? And the most important feature is that if you define a function, for example, probably we have add 3 function, okay, and you can use dot notation with user-defined function. So x is this one. I don't know, hopefully works. Okay. So I have my function, add3, or whatever function you want, that you program it and think it to takes with one number. Now we have to apply it to a vector. Just put a dot here, and the function is applied element-wise. Okay. You have comparison, like usual, so the equality, this one, okay. Minus, less, greater, greater than, less than, inequality. So what happens here? You can type like this. So exclamation mark equals. If you have ligatures in your editor, already becomes the inequality like this. Okay, if you have installed the ligatures in your editor, that makes this comes to this, okay, classic things. But you can even type this character in Julia, okay? So you go here, bam, bam, and Julia says that you can type this like this one. So \nadi negation, and okay, similar for the other one. So \less or equal LA, and \greater or equal GA. Okay, or if you have ligatures, just type and becomes okay. Nice. The none that we have already seen is equal that we have already seen, finite, and so on. We see this. Chaining, you can chain comparison, okay? This can be very useful for the math parts. You have epsilon that have to be from 0 to 1, and you can just check like this, okay? there is the and concatenated between them. Okay, we have done, okay. Now associativity. So it depends, I mean, if you have some intuition of these works, probably you already know this, and my suggestion is to put parentheses. So if I just go typing, I don't know, something like this, I don't know in which order they are computed. How Julia works, Julia have a number associated to every operation. Okay, so there is the plus that have 11 dot times 12 power much more. So Julia know which go first. Okay, but probably you don't want to memorize all of them. So put parentheses when you have in doubt of something. And another things to say is associativity. If someone don't know what is associativity, if I try to write something like this, what this means, of course, times is associative, so is don't change nothing, but there can be this one, so I can do first this and then this, or this one, so I can do first B and C and then A. Okay, and from math point of view, there is the same, but for computer is not the same. So there is a standard operation that have left associative, so the parentheses are left. Okay, and exponentation is right associative. So on the right, what does it mean if I do something like this? Is first of all 3 at the power of 2, that is 9, and then 2 to the power of 9, that is this one. Otherwise, if I write this is, oh, that's not good to, okay, it's first 2 times 3 and then 4, okay. Associativity and floating point together can make a lot of strange stuff that I want to mention, at least one. Hopefully this works. I don't test it before. So there is the associativity. Okay, so there is I compute this one and then this one on the left hand side, and the right hand side I compute this one and then this one. Okay, so the order is different, the math is the same, but I got false because there is a floating point error. Okay, so the order is different of the operation. So what happens, I compute this number and then add this, and in this side I compute this number and then add this, and if the number, all of us know that this is 0.3, okay, but if the number 0.3 isn't writable in float 64 exactly, then I commit an error, okay, and then if I add this error with this, I get 0.6 plus an error, okay. In this site, if this one is perfectly represented and then this one is also perfectly represented, I don't have any error, and at the end of the day they are different, okay. So please make attention to this, and that's it. Okay, conversions is we have already seen with int 32 and 64. You have a rounding operation like round to go to the nearest integer, floor for the floor, so go to the lower integer, and seal for the upper integer, truncate, just truncate, never, okay. and a lot of operations, div for division integers, floor, ceiling, reminder, that is this one, modulus respect to any number, and so on. This one and this one, graded positive common divisor, and this one, and so on. So there is a lot of, I mean, if you search for the function, the standard function are of course implemented, and there is even this function that is the accurate implementation, where if x is near to 0, this one is near to 0, and there is an efficient and accurate implementation about that, even similar for the logarithmic, exponential, and so on. Okay. There is even special function.jl that is a library with special function. For example, if you want to use I don't know, factorial, there is a Bessel function or other things. They have already implemented the Bessel. These zeta, gamma, enjoy. You can search for it, but and there is a lot of function. Just to search it if you need something. You can use complex number and rational numbers, just rush them. The important things to do is to say the notation is this one. So you don't have E, you don't have J like other languages. Why? Because E and J are usually used for the cycle. So, and I want to do something like this. If E is equal to 3, I want to do this to I, or same for J, and so they reserve E, I and J for this kind of operation, and for complex number we have IM. So all complex operations are implemented, multiplication, division, plus, minus, power, and so on. That's all good. You can get the real part, the imaginary part, the conjugate, absolute value for the module, the angle. So if you want to go in radians, you have the absolute value for the modulus and the angle for the theta, and so on. If you take square root of -1, takes an error, because is not initialized like a complex number, but if you use it as a complex number, then you get this right. You can even use this one, complex, if you don't like IM, and so on. You have rational numbers, I mean fractions, with operation with fractions, so simplifications, extract numerator, denominator, comparison, multiplication, exactly as with classical math fraction. And that is nothing to add, I think. Maybe if some of you wants to already start to take some exercise, go maybe in function. Cosa? Boh, possiamo fare 5 minuti però per definire le funzioni e basta. Okay. Probably in next lecture we see strings, functions in detail, control flow, that is else if, and so on, and the scope of variable, that is where the variable are defined, okay, that are important. And now we have, and then so the next lecture probably see these topics, and some exercise, hopefully, or in the next lecture even. But if some of you want to go in exercise.org and try some easy exercise, you have to know how to define function. The notation of function is pretty like MATLAB, so you have to start with the function name and then the function with the end. Okay, this f is the name of the function, and these one are the parameters of the function. Okay, and the function have to need a return if you want to return something. Okay, something of output. That's pretty fair enough. And you can use, of course. Yes. Okay. And the return even escape the function, I think. So this one return this and not the last line, cause a function to return immediately. Okay. Otherwise, if you don't put this, they compute and return this. And there is the return nothing like there. Eccolo. You have the return nothing if you want to don't return nothing, otherwise thank you. And this is the function. You can even use strange symbols if you want. You can define inline like this. Okay. And important things, modifications. So the parameters are passed to the function, okay, and you can mutate that, okay. So in this case, if x is a vector, I pass to the function f, okay, as an input, and then I mutate the x, okay, the x, the vector, then x has been muted, okay. This can be annoying if you don't want to do this, but it can be even helpful for some functions. And if you plan to modify the input as default, it's not mandatory, but is recommended to name the function starting with an exclamation mark. Okay, so this function, okay, okay, this function mutates x. Okay, so I call it like this. Okay, I can't call it like this. Cosa? And then thank you. And when you go to Julia documentation, if you see a function with an exclamation mark in the name, means that modify the input. For example, if you have a list, you have to add an element at the end of the list. You have a function that is calling some name with exclamation mark at the end. You put the function, you put the list inside the function and return the same list that has been modified with the new value at the end or at the beginning or whenever you want. Okay, I think that for today is okay. If you have any questions or